Imagine a world where your power bill is zero because your electricity comes straight from a black hole. No more worrying about forgetting to turn off the lights, just infinite cosmic energy. Yeah, that'd be weird, but not as weird as what scientists are actually proposing. In the realm of futuristic energy ideas, black hole mining might just take the cake. Why? Because apparently regular solar panels and nuclear reactors weren't extreme enough. Someone looked at a cosmic void of destruction and thought, hey, let's power our civilization with that. But here's the kicker, it's real physics. Scientists have theorized that black holes aren't just insatiable cosmic vacuum cleaners, they're also potential powerhouses. If we could harness their energy, we wouldn't just solve our energy crisis, we'd unlock power on a level we can barely comprehend. No more fossil fuels, no more solar panels, just pure unlimited energy straight from the abyss. Sounds insane, it is, but the science behind it is real, and today we're breaking it all down. Welcome to Infinitia Verity, where we take mind-blowing science and turn it into digestible, cartoonish chaos. Ready to explore the wildest energy source in the universe? Let's dive in. Our story doesn't start in one place or time, it starts everywhere. Black holes are scattered throughout the universe, lurking in the dark like cosmic vacuum cleaners, swallowing everything unfortunate enough to cross their path. And while that sounds terrifying, some scientists are now looking at these abyssal monsters and thinking that power plant? But why? Because humanity has a little problem. It's hungry, not for food but for energy, and the more advanced we become, the bigger our appetite gets. We're already pushing the limits of what the Earth can provide, and future civilizations will need power levels beyond what today's grids can even dream of handling. Throughout history, we've leveled up our energy sources. First, we burned wood, then we upgraded to coal, then oil, then nuclear. And now we're dabbling in renewables like solar and wind. But even with all of this, our energy demand keeps skyrocketing. Fast forward a few centuries into the future, and we'll be using so much energy that today's power plants will seem as outdated as medieval torches. Enter black hole mining, a solution so extreme it makes nuclear fusion look like a campfire. But before we get ahead of ourselves, let's talk about the Kardashev Scale. Created by Soviet astrophysicist Nikolai Kardashev, this scale measures how advanced a civilization is based on how much energy it can harness. Type 1 civilization uses all the energy available on its planet. We're barely at this level, more like a Type 0.7. Type 2 civilization uses all the energy from its star. Think Dyson spheres surrounding the sun, like in sci-fi movies. Type 3 civilization uses the energy of an entire galaxy. This is the stuff of galactic empires and god-tier technology. Right now, we're crawling toward Type 1, but black hole mining, that's a power source fit for a Type 2 or even Type 3 civilization. If we ever want to become an interstellar species, we'll need energy sources on an unimaginable scale, and black holes, they might just be our golden ticket. And here's the crazy part. A spinning black hole can store energy equal to hundreds of stars. That's like having a cosmic battery the size of the sun. But with one small catch, get too close and you'll be spaghettified into oblivion. Not exactly a user-friendly power source. But if we can figure out how to tap into this energy without falling in, we'd unlock the most powerful fuel source in the universe, and that's exactly what some scientists are trying to figure out. So, we've established that future civilizations will need ridiculous amounts of energy, and black holes might be the ultimate power source, but how exactly do you mine a black hole? I mean, it's not like you can just plug in a giant cosmic extension cord, right? Turns out extracting energy from a black hole is possible, at least in theory. The idea isn't new. Scientists have been debating ways to harness black hole power for decades, and they've come up with a few mind-blowing methods that sound straight out of a sci-fi novel. There are three main ways scientists think we could extract energy from a black hole, each one crazier than the last. First up, we have Hawking radiation. This one comes from none other than Stephen Hawking, who realized that black holes aren't completely black. Thanks to quantum mechanics, they actually leak tiny amounts of energy over time. This process, called black hole evaporation, means that a black hole is slowly losing mass as it radiates energy into space. The good news, if we could harness this radiation, we'd have a steady source of power. The bad news, the energy output is incredibly weak unless the black hole is tiny, like the size of a mountain, which means we'd either have to find a small black hole, good luck with that, or create one ourselves, which sounds mildly terrifying. Next up is the Penrose Process, first proposed by physicist Roger Penrose in the 1960s. This method involves tossing an object into the black hole's ergosphere, a weird region around a spinning black hole where space-time itself is being dragged along. If you do it right, the object can split into two, with one part falling in and the other getting flung outward with more energy than it started with. Think of it like this. You're throwing your trash into a cosmic whirlpool and somehow, instead of getting rid of waste, you get free energy in return. Sounds ridiculous, but the math actually works. And finally, we have the Blandford-Zienicek process, which is basically the black hole version of a giant power generator. This method involves using the magnetic fields around a spinning black hole to extract energy from its rotation. In simple terms, you'd slap a cosmic alternator onto the black hole and boom, free electricity. This could be one of the most efficient ways to extract power, but there's just one tiny problem. We'd need to build an advanced energy harvesting system right next to a black hole. Yeah, that's a big yikes. Physicist Roger Penrose once theorized that black holes could be used as energy sources, and Stephen Hawking backed the idea with quantum mechanics. But let's be real, neither of them was thinking, one day humans will use this to charge their smartphones. Basically, it's like everyone pitching in for a pizza, but only the king gets to eat it. Black holes are hoarding all the energy, and we just want a slice. So, can we actually build a black hole power plant? Right now, no, we don't have the technology to safely get close to a black hole, let alone extract energy from one. But in the far future, if we reach Type 2 civilization status, this could be our reality. And when that day comes, power plants won't be ugly smokestacks or solar farms. They'll be cosmic dynamos harnessing the raw energy of the universe itself. And then, could it happen? Scientists stopped treating black hole mining as just a crazy theoretical idea and started running real calculations on how it could actually work. What started as a thought experiment turned into serious physics papers, with proposals ranging from capturing Hawking radiation to constructing massive energy harvesting stations around black holes. Because, you know, humans love turning the impossible into engineering problems. But before we start picturing futuristic space factories orbiting black holes, let's break this down. How exactly would we build a black hole power station? Let's take it step by step. Step 1. Choosing the right black hole. Not all black holes are created equal. Some are too massive, others too small. If we're going to mine energy from one, we need the Goldilocks zone of black holes, just the right size and spin rate to be useful. Scientists think a rapidly spinning black hole would be the best candidate because its rotation is what makes the Penrose and Blandford-Zienicek processes possible. Ideally, we'd want a black hole just a few times the mass of our Sun spinning near the speed of light. But there's a catch. The closest known black hole to Earth, Gaia BH1, is over 1,500 light-years away. So unless we find a closer one or make our own, we'll need some serious interstellar travel before we can even get started. Step 2. Building a space station near a black hole without dying. Okay, so we found the perfect black hole. Now, how do we set up shop without getting turned into cosmic spaghetti? We'd need to build a space station in a stable orbit around the black hole, close enough to extract energy, but far enough to avoid falling in. And it would have to deal with intense gravitational forces, radiation, and time dilation. Yeah, that's right. If you worked on this station, you'd age slower than everyone back home. Imagine going to work for a year and coming back to find out your great-great-grandkids are now older than you. But let's assume we figured out the engineering. Once we've got our black hole mining station set up, we can start extracting energy using one of the three methods we discussed earlier. Hawking radiation, the Penrose process, or the Blandford-Zanarjek process. Step 3, beaming the energy back to civilization. One idea is to use giant laser beams to transmit energy wirelessly across space. This concept, called power beaming, is already being researched on Earth using microwave and laser transmission. In the far future, we might have interstellar power grids where energy from black holes is beamed across the galaxy to planets that need it. Sounds wild. Sure. But so did Wi-Fi 100 years ago. Imagine the first engineers assigned to the black hole mining project. So, you want me to approach a cosmic death trap, harness its energy, and somehow not die? Yes. Cool, cool, cool. Totally normal job. What happens if something goes wrong? Scenario 1. The energy harvesting system fails. If our energy extraction mechanisms break down, we basically have a giant, useless space station orbiting a death vortex. At best, it's an expensive waste of resources. At worst, well, let's just say we don't want a power surge from a black hole. Scenario 2. The black hole starts feeding too fast. Black holes grow when they consume matter. If we accidentally overfeed one by, say, dumping too much material into it during the Penrose process, it could start expanding faster than expected. That's bad news if it's anywhere near inhabited space. The last thing we want is to turn a harmless power source into a cosmic doomsday machine. Scenario 3. We accidentally create a black hole on Earth. Oh, and here's a nightmare scenario. If we create artificial black holes as power sources, there's always the chance of losing control. Some scientists have even theorized that microscopic black holes could be formed in high-energy particle collisions. If one ever escaped containment and started absorbing matter, well, let's just say Earth wouldn't have an energy crisis anymore, or anything anymore. Stephen Hawking once wrote, "Black holes ain't as black as they are painted." Translation: hey, maybe we can actually use these things. A small black hole, just a few kilometers in diameter, could output more energy than all the power plants on Earth combined. Some scientists propose that future civilizations could move black holes to different locations, basically turning them into interstellar power generators on demand. That's right. Black hole transportation might be a thing one day. In the sci-fi novel The Three-Body Problem, aliens use a miniature black hole as a power source, but let's hope our attempts at black hole energy don't attract any unwanted visitors. If we ever master black hole mining, it won't just change energy production, it'll change everything. A civilization powered by black holes would be able to expand across the stars, build structures beyond our imagination, and potentially even manipulate space-time itself. In simple terms, it's like upgrading from burning wood to harnessing the energy of entire stars. Fossil fuels, solar panels, those would be ancient history. So, what happens after we successfully build a black hole power plant? Well, for starters, humanity's energy crisis would be over. No more fossil fuels, no more limited power grids. Instead, we'd have an energy source so vast that we could power entire planets, space colonies, and interstellar spacecraft for millennia. But let's be real, there'd probably be a few unexpected side effects. Governments would argue over who gets to control black hole energy. Power companies would probably find a way to still charge you for infinite energy. And conspiracy theorists, oh, they'd have a field day. What if the government is hiding black hole power from us? This isn't just about energy. If we harness black holes, we'd take a massive step toward becoming a Type 2 civilization on the Kardashev Scale, and that means interstellar expansion, space megastructures, and possibly even manipulating space-time itself. In other words, black hole mining wouldn't just power our future, it is our future. And funnily enough, this means that one day, your electricity bill might read Supplier Intergalactic Black Hole Energy Corp. Late fees will result in gravitational doom. And there you have it, black hole mining in a nutshell. We started with humanity's endless hunger for energy, explored the wildest power source in the universe, and broke down how we might actually extract energy from a black hole, without getting sucked in, hopefully. Who knew that the deadliest objects in space might also be the key to an energy-rich future? It's like discovering that volcanoes could charge your iPhone. Terrifying, but also kind of genius. If you enjoyed this mind-bending dive into the future, don't forget to like, subscribe, and hit that notification bell. We've got even crazier topics coming your way. Next time on Infinity Verity, we're diving into the real possibility of warp drives. Yeah, faster-than-light travel might actually happen.